All right, so here's our video on constant acceleration motion. Show you a couple examples, all ranked from easiest to easy to difficult. In other words, medium, mild, and spicy. Before we start, just as a quick review of our physics equations, our toolbox, the things we're allowed to use. And they're organized. So if you have a constant velocity motion, this is the only equation you can use. If you have constant acceleration motion, these are the equations you use, all right? Now there's one more that's an always equation, but it's very specific. If they're asking for average velocity, you always do the total distance divided by the total time, and that's an always thing. It doesn't matter what motion you have, all right? So let's get to the first problem here, our medium problem, all right? Following along with that PDF, and you can see that we have Chuck starts from rest and reaches a speed of 15 meters a second in 4 seconds. So from reading that, what's going into my brain is we have an initial velocity of 0 because it starts from rest. We have a final speed of 15 meters per second because it says it reaches that speed, and the time is 4 seconds, all right? First thing I want to know is what's the acceleration. So I go to my physics toolbox, A equals delta V over delta T. I can see A is a final velocity. Remember, this is final velocity minus initial velocity over time. That's what delta V stands for. Then I just see my final velocity is 15, my initial velocity is 0, and my time is 4 seconds. All right, it's a little awkward number there. So 15 divided by 4 gives me 3.75 meters per second squared. That's the unit for acceleration. All right. Now part B says, how far did the truck travel in those 4 seconds? Remember, we cannot use this. That's out. That's a constant velocity. All right. We have a final instantaneous velocity of 15, initial velocity of that, but we're not at a constant velocity. So we got to go to our physics toolbox. We know we're in constant acceleration. So I see delta D. That's my first look. So we go delta D equals a V initial of 0 times time, which is also going to be 0. So 0 times, 4 seconds plus 1/2. Acceleration I see here is 3.75. And my time is still 4, and that gets squared. Now I can go to my calculator, and I can see delta D equals, let's see here, 0.5 times 3.75 times 4 squared, which is 16, and I have 30 meters. All right, and that's how we do our first problem. Or I should have put this up here. This is number 1. All right, ranked on a spicy scale of just medium. This is pretty easy. It's pretty straightforward. Yeah, there's our first one. Let's go to number 2. All right, so now for number 2, our mild ranked problem. All right, it's number 2. So when I go through and read this thing, let's see, we got a car accelerates. All right, so notice I'm just writing down the stuff I know from here so I can see it, -5 meters per second squared. All right, for a distance of 100 meters. And then it says that the car had an initial velocity, V initial, of -3 meters per second at the start. What do we want to know? We want to know the car's final velocity. So I see I have A, I have VI, I have delta D, but I don't have time. And it's not asking for time. So it's a dead giveaway to use my one equation that doesn't have time. VF squared equals VI squared plus 2A delta D. All right, I'm looking for VF squared, and my V initial is -3 plus 2 times -5 times a distance of 100 meters. Now this is tricky. This is trickier than I thought. It says a distance of 100 meters, but this is almost kind of assumed, and this is harder than I thought. And so on a quiz or a test, it would be a little clearer. if you are traveling at this speed here, and this velocity here, which is negative, and you have that negative acceleration, that means you are speeding up in the negative direction, which means you are also traveling in the negative direction. So your displacement will actually be negative. And if you don't put that negative in there, then you'll just put a positive, and that will change your numbers around. All right, that will affect the final outcome. All right, so that's tricky reading on there. I didn't actually intend for it to be that hard, but there you go. All right, giving you some experience. Again, if you're moving in the negative direction, you have an acceleration in the negative direction. That means you're speeding up. You're going to be traveling in the negative direction, so your displacement is going to be negative. Once we had that, we can go to our calculator. All right, by the way, this is squared too. We have -3 squared plus 2 times 5 negative times 100 negative. And we have VF squared equals 1009. And then VS, so we take the square root of each side, and that's going to give us 31.8 meters per second. Now, it's asking for the car's final velocity. When we take a square root of something, remember that is plus or minus. So which one is it in this problem? Well, since we're moving in the negative to start, we are speeding up in the negative, we are traveling in the negative direction, we have a displacement negative, our final velocity is going to be in the negative direction. So we can apply which one we need here, and we have negative 31.8 meters per second. All right, be careful when you do this equation. When you solve for the final velocity, you're taking a square root, it can be plus or minus. Make sure you apply which one it is, and that comes from reading, all right, and understanding what's going on in the problem. Okay, so that's part A. Part B, how much time did it take? All right, well, I know I have acceleration, I have final velocity, I have initial velocity, so I'm just going to go A equals V final minus V initial over delta T. I have A, which is, what is A? A is -5. -5 equals a V final of -31.8 minus an initial velocity of -3 over delta T. Multiply both sides by delta T, algebra. So I have delta T times -5, so delta T, -5 equals, I'll do all this up top there, -31.8 negative minus 3 negative gives me -28.8. See, I divide by -5, simple algebra, and I get a delta T of -28.5 divided by -5. What I divide by -5 gives me, divided by 5, negative, and I have 5.76 seconds. 5.76 seconds. All right, and that's the easy way to do this. Now, there's a harder way to do this, and I'll show you that, and I'll show you the problems of doing this the more difficult way. All right, so we're trying to find time. Well, maybe I want to use this equation. Delta D equals V initial delta T plus 1/2 A delta T squared. All right, so our delta D is -100, we know that. Our initial velocity is -3, time we're looking for, plus 1/2 times -5 times delta T squared. In this equation, we have one unknown, just delta T. So when we do this, we have -100 equals -3 delta T minus 2.5 delta T squared. Now at this point, look at this equation. This is a polynomial, all right? So you'll have to factor, or not factor, but use a quadratic equation, whatever you need to do to solve for that. And most of you guys are not good at that. It's hard, all right? And it's inconvenient. So recognize when you're solving for times and you have an initial velocity, this may be a hard equation to use. So just switch over to your easy way of doing it, all right? Now to finish off this problem, all right, we want to find the car's average velocity. So let's erase this. Average velocity is always, always, always the same equation. It doesn't matter what type of movement we are going in. Delta D over delta T. So our average velocity equals our total displacement, which in this case is negative 100. And the time we just figured out, shoot, I just erased it and I don't know what it was. I think it was 5.76. I don't know. Look back in the video. Well, actually, I can do it. Let's see. What was it? 31.8, I think. Minus 3 equals divided by, what was the acceleration? 5. Yeah, close enough. 5.76. It was about there. And we get an average velocity of 100 negative divided by 5.76. And I got negative 17.4 meters per second. The negative tells us the direction. Remember this, in this whole entire problem, everything was going in negative direction. So when we have our vectors, we must give the units. All right, and that's how we do number 2. It was ranked mild. Yeah, it was a little bit more difficult than I expected, particularly with that negative 100 displacement, trying to figure that out. All right? Okay, so in problem number 3, our spicy problem, because it's a little bit difficult, we are only solving for one thing, and that's the average velocity of the car. Now, the problem is there's a lot going on here. So it's a longer problem. We're going to have to get organized. I'll show you what this means up here. But remember what we're looking for, average velocity. So there's a whole bunch of stuff going on, but it doesn't matter because our equation for average velocity is always this. Always, always. Doesn't matter what's going on. Now, in this problem, after reading it, I see there's 3 parts. There's a speeding up part when he hits the gas. There's a constant velocity part when he's cruising. And then there's a slowing down part when he hits the brakes. And what we need to do is solve for the total distance for the entire thing and the total time for the entire thing so we can get our average velocity. All right? So we're going to take that in each step, all right, or each period of motion, our first motion, second motion, and third motion. So let's just do part 1, all right? In part 1, we have an acceleration of 5 meters per second squared. We have a time of 4 seconds, all right? So that's kind of good. We already have delta T1 is 4 seconds. But we don't know the distance that he travels in the first time. So it's constant acceleration. We're going to use our constant acceleration equation. Delta D equals V initial, which is 0 because he started at rest because he had a stoplight, plus 1/2 times 5 times 4 squared. That gives us a distance of, let's see, 16 times 2.5, distance of 40 meters. So now I have delta D1 is equal to 40 meters. So we have everything we need for part 1 here. All right, we have its distance and its time. Now we'll move on to the middle part. So now we'll do part 2, which is our constant velocity. So we have V equals delta D over delta T. We already know delta T is 10 seconds, but we don't know how far he moved. And not only that, we don't even know how fast he's moving. So the key there is to go back to here and notice that its final velocity in part 1 is his speed for the whole part 2. So let's go and solve for final velocity here. Well, we're in constant acceleration. So I'm just going to do, I can get rid of some of this stuff here with my eraser. All right, I'm going to keep this. All right, I'm going to write that down separate on a separate piece of paper for me. Let's see, delta T1 is equal to 4 seconds. Delta D is equal to 40. All right, so now to solve for the final velocity for part 1, well, I have the time. I'll just use A equals V final minus V initial over delta T. A I know is equal to 5. V final is what I'm looking for. It starts from rest and the time is 4 seconds. So that goes up there, algebra, and I get V final is equal to 20 meters per second. That allows me to now, so remember, so he reached 20 meters per second at this point, and so therefore he stays at 20 meters for the whole next time he's cruising. Switch over to here. I can now plug this in as 20. I have delta D. I have a time of 10 seconds, 10 seconds. 10 seconds. And my delta D is now 200 meters. So my second time is 2 seconds. My second distance is 200 meters. And I'm gonna write that down separately. All right, over here off camera, because I'm gonna need these things to erase because I don't have a lot of them. My time is 10 seconds. So we've gotten everything we got from the second part here. Our distance and time we got from this part. Now we have to do our distance and time for the third part. So let's check that out. I've written all this down. Now in the third part, let's see what we have. We have our time, which, no, we don't have our time, we have our distance. I read that wrong. Distance is equal to 7 meters, all right? But I need its time, all right? I also, and that's all I have, all right? So maybe we're stuck here. I don't know, let's figure this thing out. The one other thing I do know is V final is equal to 0 because he has to slam on his brakes and he's gonna come to a rest in that amount of time, all right? So let's see, I have, I have one other thing. I have V initial is equal to 20 meters per second. Why? How do I know that? We'll go back to our organizational chart here. He gets to 20 meters per second here, stays at 20 meters per second for all this constant velocity, and then when the deer runs out in front of him, at this point, he's still going 20 meters per second there, and he slams on his brake by here going to a speed of 0. Okay, so let's check this out. I don't have acceleration, I don't have time, but I have delta D, V final, V initial. What equation am I going to use? I'm going to go with V final squared equals V initial squared plus 2A delta D. Let's see what I can solve for here. V finals is 0 equals a V initial of 20 squared plus 2 times A times 7 meters. All right, this goes over here as negative 400. All right, remember that's going to go over there, subtract it over. 2 times 7 is 14A. Divide by the 14 using simple algebra, and I get 400 divided by 14 gives me 28.6 meters per second, and notice squared, and notice that's negative, which makes sense because he's slowing down. All right? But I still have to get time. All right, so how am I going to get time? Let's erase some of this because I don't need it. All right? I have the acceleration now, so this is part 3. Acceleration equals V final minus V initial over delta T. My acceleration I just saw is negative 28.6. My V final is 0 minus 20. I think I screwed up somewhere, but let's see. Minus 20 over delta T. And hold on, let me check my math real quick. Squared divided by 2 divided by 7 gives me... Oh, so wait a second, hold on, let me look. Got that, something I don't like here. Oh, no, sorry, we're fine. I was thinking ahead, being weird. Okay, so let's solve for this. I'm gonna work up here. That delta T is gonna get multiplied up there. Negative 28.6 delta T equals negative 20. Delta T is equal to negative 20 divided by negative 28.6. And I have a delta T of only 20 divided by 28.6 of only 0.7 seconds, because those will cancel out. And there's my final time. So let's write this down over here, my times, and I'll review, I'll put all them back up here, and a distance of 7. So now I have all of my times, all of my distances. All right, so let's put it all together. All right, I'll erase this here. Yeah, why not? I'll rewrite it. Give me some room. So I know for the first part, all right, for this part here, all right, all that part there, I figured out a distance of 40, a time of 4 seconds. For this part, I solved a distance of 200, a time of 10 seconds. And for this part, it was a distance of only 7 and a time of only 0.7. So if my average velocity is equal to, for the entire trip, it's the displacement of the entire trip divided by time in the entire trip. So I'm going to add all those up. So it'd be 40 plus 200 plus 7 all over 4 plus 10 plus 0.7. So we get the average velocity of the top part is 40. Well, that's easy. 240.7, and on the bottom that's 14.7. So now 240.7 divided by 14.7 gives me 16.4 meters per second. All right. So that's a lot of work for just one answer, but we split up into 3 separate parts that we had to connect with certain particular values. All right. And I think that gives us a pretty good overview of constant acceleration problems. We saw how to deal with negative things. We saw how to do with multiple parts, constant velocity, average velocity, doing weird things, and just an easy, simple constant acceleration problem. All right. So thanks for watching, and see you when I see you.